Which computer? Okay. Hi everyone. This is let's discuss a paper right after reading it. In this journal club, we selected and started reading a paper 2 hours ago, and then from now we are going to discuss the paper. Today we have two people, Changshen and me. Changshen, can you introduce yourself first?
Okay. Hello, everyone. My name is Qian Chen, and I'm currently a PhD student from Monash University, Australia.
Hey, thank you, Changshen. Me, Yota Kawashima. I'm doing research assistant in Japan. Today we are going to read a paper titled An Adversarial Corroboration Protocol for Testing Contrasting Predictions of Global Neural Workspace and Integrated Information Theory by Lucia Meloni, Liad Mudrik, Michael Pitt et al. 2023 from PLOS One. This paper is stage 1 registered report. So mainly research from, but it's interesting. So we're gonna discuss this paper. But anyway, so before discussing this paper, I will give a brief summary of this paper. This paper is long. This study includes two experiments, and each of them tests different predictions from the theories. I mean, the global workspace, a neural workspace theory, and IIT. So in this discussion, we only focus on experiment 1, and we'll not talk about experiment 2. But anyway, so why this research, the motivation? So since 1990s, Christoph Koch and Francis Crick proposed the framework NECC approach. And since then, researchers have accumulated findings about the neural substrate of consciousness and start to propose a theory of consciousness, like, again, integrated information theory, global neural workspace theory, higher order theory, blah, blah, blah. But the problem here is that we don't know which one is more plausible, and there are no crosstalk among these theories. So the same author of this paper, the Meloni, Mudrik, Pitts, and Koch, proposed an research framework in 2021 Science, adversarial correlation. And the idea is that we design an experiment where the different theory make different prediction on the experimental result and see which theory is more plausible. And this is the idea of this adversarial corroboration. This paper, PLOS One paper, also, or just focus on two theories, global neural workspace theory and IIT. See what kind of prediction the theories make on the experiments. And here I will not explain the detail of each theory because we've already talked about them in episode 37, where we talked about review paper of theories of consciousness. So I'll just quickly explain each theory. So global neural workspace theory. It's talk about the for conscious experience, and the so-called global ignition is important. So some unconscious processes is going on, and once the processes enter the global work, global workspace. The information is shared or distributed globally. So the main, idea of this theory is that the interaction, communications between frontal parietal with sensory areas is important for consciousness, or the information will be shared if participants are conscious of the stimuli. That's the global neural workspace theory. And the IITs, on the other hand, it starts from the axiom, 5 axioms. And from these axioms, they make a proposal of mathematical framework to quantify the consciousness. Then they make a prediction that conscious experience, posterior area, so-called posterior hot zone, is important. So basically the frontal area is not necessary for conscious experience. And that's the main prediction from IIT. Yeah, so in this research protocol, they compares basically these two predictions, the locations. So that again, the global neural workspace theory, GNWT, predict the frontal parietal with high level sensory area is important. On the other hand, IIT predict the posterior hot zone is enough. That's about the location. And also, if we do some decoding, then we should be able to detect or decode the contents of experience, conscious experience, from this, frontal parietal and higher level sensory areas, according to global neural workspace theory. On the other hand, IIT predict that the decodability is maximal at posterior hot zone. That's a prediction about decoding, but I guess it's somehow related to the location prediction about record locations. And another predictions is that temporal dynamics. So again, the global neural workspace theory talk about ignitions. So there are some temporal dynamics of neural activities that is related to global ignitions. So that should be able to be observed in the neural activity. On the other hand, IIT says that, when we see something, we should have a kind of fixed, neural activity or states as long as we see. So we should not see that kind of, temporal dynamics while having one conscious percept. And so far I have talked about 3 predictions: location, decoding, and temporal dynamics. These predictions are related to experiment 1. And again, this paper include or propose another experiment 2, which also test different predictions, but I will not talk about these, the remaining predictions about the experiment 2. Okay. So from now, I'm gonna talk about experiment 1, the task design. So the task design, or what the authors try to do in experiment 1, is to manipulate the task relevance for seeing stimuli. So they did not, manipulate the conscious perception of the stimuli. Basically, what they did is just, change whether the stimuli is relevant for task or not. Right. So in the task, participant will be presented a series of images interleaved with blank. And the stimuli will be either pictures of face and object or symbols, including letter and just a false font. So we have two classes of stimuli, pictures and symbols. And in one condition, this pictures is related to task or relevant to task. So participants will be instructed to detect faces or object that is specified during the instruction stage. So again, the participants will be seeing images, series of images, and then once they see matched faces or object, they will report or make button response, I think. And then of course, during that task, task relevant, but not specified in instruction images will be presented. For example, like just different faces or another person's faces or just different object. And also, of course, task relevant symbols will be presented. So this is basically how they manipulate task relevance of stimuli. And so the prediction from the theories, the first of all about the decodability, as long as participants, or the assumption is that the participants will always see the presented stimuli given the stimulus durations. So we should be able to, decode the contents of experiences, which means the stimuli presented. But the difference between these two theories, neural workspace theory and IIT, is from where the brain lesions. So the first global neural workspace theory says that we can decode that information, the stimuli, from frontal areas. On the other hand, IIT says that stimuli can be decoded from the posterior areas. That's predictions, and we can see the difference compares these two theories in that sense. And another thing is that temporal dynamics, again, the global neural workspace theory says that the ignitions is important. So we should be able to see some transient activity at around the stimulus onset and offset. On the other hand, IIT says that as long as we see something, the state should be the same. So we should be able to see similar activity pattern while we're consciously seeing something. That's the another predictions, the different predictions. And the final prediction is again somehow related to decoding analysis, but global neural workspace theory says that global interactions, communications is important. So it predicts that the long-range synchrony between frontal areas and category selective areas in sensory cortex will be observed. On the other hand, IIT says that the synchrony will be localized. I mean, within the sensory areas between category selective areas and laudable visual areas. And again, that's different theories predict different things, different observation from the result, from the experiment. Anyway, so that is experiment 1. And as I said before, this is still stage 1 of RegStat report. They are now doing experiment recording brain activity. So we don't know what kind of result they will get. But I forgot to mention one interesting thing is that, this research involves a lot of researchers and a lot of laboratories, and they take this and reproducibility seriously. So they basically ask some two different laboratories to do the same task or to collect the same data, and then analyze the data to see whether we can see the consistent result from two different laboratories. And also, they asked or they selected these, data collecting labs so that they are not biased toward one theories. Of course, if you are a proponent of IIT, then somehow or maybe they try to do something shady to support IIT or something. So yeah, they think about that.
I think what you're trying to say is if they get results that support IIT,
Yeah.
then people will start to in turn question whether they have done shady things.
Yeah, exactly. Yeah, but anyway, so this research proposal or protocol is so inclusive. They also trying to recruit almost like a double sample as compared to the standard studies. That's what it says. And they record not only fMRI, but also like EEG, intracranial EEG, and MEG EEG. So not specific to one measurement. I mean, not specific to one recording device, but try to find more robust trying to make the robust findings. And yeah, that's it basically. Yeah. And if you have any comments, question, please go ahead, Shen.
Thanks for the summary. I think the summary is great, and I don't have things to add.
Yeah.
It's very hard to raise any questions seeing the authors list. But I'm still gonna ask it.
Okay.
So I think for this experiment alone, for this experiment one alone, a very important assumption of this experiment is that we have this pure conscious experience of a stimulus that is invariant to the task relevance. And because of this pure conscious experience exists, there's also this pure brain mechanism that correspond to this pure conscious experience, both invariant to task relevance. My question is there really such pure experience? So do task relevance itself interact and alter experience of the stimulus, right? And I think it is possible, considering task relevance can generate expectation and prediction, which can have top-down effects on the sensory processing. And also, there used to be a I think face perception paper by I think Now and Elise collaborated in that paper, and it's about asking people to see a lot of faces. So the paradigm is similar to this one, where they show them a target face and then show them a series of faces. But the actual interest in that experiment is to test whether people remember seeing or consciously experience those task irrelevant faces. And they actually had this demo GIF That's on our lab website. If you look at that GIF yourself, you find that, you know, it's just how it's amazing how you quickly forgot the task irrelevant phases. And if you backtracked it's actually possible that your experience of the task irrelevant phases could be different from the task relevant phases. So yeah, that's my first question. What do you think?
So yeah, I agree that, you know, some contextual effect will be there.
Mm.
So we have read several papers about you know, assumptions, implicit assumption in a cognitive science in general. And your question is kind of related to that.
Yeah.
You know, we have some, you know, ideal mechanisms,
Mm.
and that should be, you know, observed independent of task design and other conditions. But the question is that, you know, do we really have that kind of, you know, ideal mechanism, or, you know, do we see the same thing or samely in different conditions? So yeah, I'm not sure about that, but one thing I can say is that, you know, and in any case, what they try to do is just to compare the two, you know, theories, and there will be no differences regarding the task relevance, I guess.
I guess this issue is probably equally problematic for both theories because the region of interest for global neuronal workspace theory is the prefrontal cortex, right? This area is famous for executive function, and it's hard to imagine it does not elicit any difference in activity when you manipulate the task relevance of the stimulus. And you have no idea whether it comes from an altered experience or it's some kind of noise coming from, you know, that same region carrying the task relevant functions, which interferes with the experience. Yeah. And for IIT, its axioms already postulate that your experience is an integration of many different elements, which would definitely, you know, involve, you know, how your conscious state may change when you are simultaneously carrying some kind of task. And because of these different elements that the conscious experience integrates, then it may alter the experience itself, hence a different cause effect structure. That's also possible.
Mhm.
So
I see. Yeah. Hmm. And to be honest, you know, when I read this paper, I kind of have the same feeling because they use the term task relevant, right, images. But, you know, the participant, as a participant, you know, perspective, from the participant perspective, you know, they are doing task, and then the image will be presented. So all images is kind of related to task, right?
yeah, and that too.
Yeah.
Mm.
So in a narrow sense, yes, that's, you know, there will be differences. We have task relevant and task relevant stimuli, but in a broad sense, all images are task relevant, and that might be, you know, might affect the, you know, interpretation.
Yeah. So I feel like they can also do like this very baseline task where they just have people sitting there and just looking at the images without doing any task.
Mm.
I'll talk about this kind of thing a lot of times, right? It's like, no experiment on this, just having people sitting there. They just always ask people to do a task or something like that. And I think only under that kind of setup where people are not asked to do any task, can you get the kind of how do I say this? On the one hand, unconditionally visible stimulus, and then on the other hand, no interference of task relevance.
Mm. Mm.
If, yeah, so like if the classifier they train from this experiment where people are asked to do a task can still work in the data set where they collected from the experiment in which they ask people to not do anything, just look at the pictures, then I would be like triple convinced.
I see. Okay, so that's true that, if the purpose is only to, compare the prediction from these two theories, then, we may not need any task. Just, passive viewing is enough.
Yeah.
But I haven't mentioned during the summary, but for some reason, they also try to find some, true near NCC, near quality of consciousness. And for that, task manipulation is important. I mean, the task relevance versus task irrelevance is important because, NCC is often to be said that, it's contaminated by consequences of NCC, such as, reporting task relevance, some cognitive, processing.
That's why they should add the passive viewing
Yeah.
where there's no task. And I also read that they said they can that way they can separate the correlates for task relevance only, and the part where your brain is doing the task but it's not responsible for consciously seeing anything, and from the mechanism that are actually responsible for conscious perception. But is there really such separation? Like, can you really find such clear separation?
Mm.
I don't know. I don't know. I guess people on the list, on the author's list, are fine with this, so I guess.
Yeah. um, yeah, I guess, I don't know. Maybe that's related to my current, project. And I'm now writing the manuscript. I hope I can submit the manuscript, the stage 1 manuscript, next month, in 2 months. I hope. We'll see. Yeah. Yokon-san might be, somehow addressed by that. I don't know.
Okay.
Yeah. Anyway.
Mm.
So any other comments, questions?
A very specific concern, which you didn't really mention in your summary. So uh, in their description of what each theory will predict about the temporal dynamics of brain activity, they talk about they make specific predictions about how, according to each theory, the brain mechanism or the neural activity would change as you change the stimulus presentation duration. For global neuronal workspace theory, of course, it's very simple. Basically, it's just the spike between onset and offset would be longer as the stimulus presentation duration becomes longer, right? But for IIT, so they made the prediction that I didn't really understand. They said it would be the the neural activity for longer duration stimulus would be stronger So not just persists for whatever duration the stimulus is presented for, but it's also stronger. I don't really understand why.
Mm, I don't, or I just, I may skip that part. Yeah,
Okay.
but I agree that in order to compare the two theories, some prediction are not that intuitive, or I'm not sure whether we can directly derive or obtain the prediction from the theory.
Mm.
So maybe that's why they mentioned that. I don't know. So which paragraph
Um,
prediction? So should be somewhere um strong. Hmm.
What's such stronger? Nothing appears. I literally saw that sentence. Give me some time. Sorry.
Yeah, I don't remember. Yeah, as you said, the IIT predict that the consistent while you are seeing that, and I understand that. But strong, is it maybe related to another prediction about the pre-stimulus activity? No.
Uh, Possibly.
Yeah. So we haven't or I didn't include that prediction because that's not related to experiment one. But this paper, they talked about another prediction about pre-stimulus.
I found it.
Oh, you
Sorry.
found it. Where?
It's in the plan analysis and expected outcomes. Number
Uh,
two, activation patterns across stimulus durations. And not on the same page of the title, but next page, first paragraph. Therefore, activation levels within posterior area should be higher for longer duration and consciously seen than shorter duration and no longer seen stimulus during analysis time window 2 and 3. Well, I have to go back to analysis 1, 2, and 3. Wait, 2 and 3 is the presentation time. So yeah, what is activation levels should be higher.
mm, yeah, I don't. Yeah, I think. Yeah, I think skip that part. So I don't know why they said that, but strong activations. I don't know. Don't know.
Mm.
Yeah, IIT, right? It's about the IIT, right?
Yeah. So I think their main point is still in the fact that it predicts sustained activity during any time durations when the stimulus is presented. But here they often mention it's higher for longer duration. So it's kind of weird.
I don't know.
Yeah.
Yeah, and I don't. Yeah, I just don't know about that, and
I
it's
see.
not clear why.
So like the shortest time duration is 500 milliseconds. So just like they said, it's all, very visible.
Oh, so but this is also difficult. Like you mentioned the visibility of stimulus. So
Mm.
in one moment the stimulus is really visible, and the other moment the invisible, or less visible. Still, you have some conscious perception of that stimuli, and in that sense, I don't know how the IIT theorists say about that, but my understanding is that the structure itself is not the same. So there should be, similar but different brain activity or cause effect power. And or but I don't know.
And also here they make a lot of like two-tail hypothesis. But I kind of imagine their results would be somewhere in the middle.
Okay. But
Although, yeah.
So if we think about the visibility or link the visibility with the arousal or the level of consciousness, if he says that, when you see stimuli more visible, you are more kind of awake, then in that sense, maybe it's possible to, have the same structure, but
Stronger activation.
yeah, kind of. Maybe that's the reason why they said that, but I don't know. And as the last author of this paper is Giulio Tononi, so if he says so, then that's how IIT works. I think. I think. Yeah. It's again, but I want to mention that this is just predictions, from the theory, and the study make these predictions to compare the theories. So sometimes the predictions is not that direct in a sense. We can directly drive the prediction from the theory. We have some other evidence saying that okay, this and this, and based on that we might be able to say that for example, this posterior hot zone, this is not of course the axiom of this IIT. So IIT does not start from that posterior is important or posterior is essential for consciousness. That's not how IIT says. IIT just starts from other axioms and then saying that this causal structure is important, and based on the anatomy in posterior area, and we can make a prediction that okay, posterior is enough to have an rich cause effect structures. So even though we don't see any or consistent finding with this posterior hop down from this paradigm, it does not mean that cause effect structure is necessary for conscious perception. If they do some proper analysis to investigate the structure and find that that structure is irrelevant to conscious perception, and then that yes, we can say that's irrelevant to conscious perceptions. But what they are doing is just focusing, making a prediction based on anatomy. So yeah, but this is again just my understanding and what other people see is different, might be different.
How they already have the stage 1 register report here, but how many papers are there? Many papers out there that look at the cause effect structures in, at least monkey brains. Because Angus's paper analyzed the information structure of flies.
Yes.
And that seems to already be computationally very, very heavy. And now they're looking at human brain. I don't know, is this very has this been a very feasible thing to do these years?
I don't think so. Of course, if we make some modified version or shortcut, we can do something similar analysis. But the proper analysis proposed in IIT theory, it's really computationally heavy, so I don't think it's possible, even like a fly and much smaller animals. Because Angus' case, he focused on only 4 kind of electrodes.
Oh.
Only 4.
Yeah, and it's already, I don't know, like he's already using the supercomputer, right, at the time.
Yeah.
So, yes.
Yeah, the reason is that, I forgot the number of electrodes, but, say we have 10 electrodes and think about the 4, sets of electrodes. So 10 choose 4. And that's, not small numbers. And as you increase the number of electrodes, that combination increase. And also if you want to investigate for more, larger set of, electrodes, like 5, 6, 7, 10, it's almost impossible if you increase the number. Yeah.
So I guess the analysis they're doing here is not the full IIT analysis, but probably a more downstream prediction that approved by IIT people in a sense. Related to IIT and predicted by IIT and is approved by IIT people, but not that they are really going to look at the informational structure.
I think so.
Yeah.
But again, I haven't read the analysis part in detail, so they may have some plan. Yeah.
It's on like the OSF registration, so we didn't have the time to go through that.
But I now skimmed through it, but I don't think mentioned anything about the IIT analysis. They talk about the decoding and some, pattern of synchronization, which I don't think require IIT analysis, because that will be also applied to global neural space theory prediction. So
oh yeah, right.
Neuronal, yeah. Activation pattern. So yeah, I don't know. Maybe, yeah, no, nothing. But so yeah. Anyway, any comments, questions?
I don't have any more. What about you?
I think yeah, I'm fine. So yeah. Yeah, I think yeah. This comments. This proposal is interesting, and I want to see the results. I don't know when or how long it will take to collect the data. I don't think they maybe somewhere they mentioned the timeline of this studies until when they finish the data recording something.
up until like the last few pages.
Yeah, but yeah, maybe. Yeah. Again, I didn't have time to read that part. So, yeah. And I didn't include the experiment 2, but experiment 2 is also kind of interesting because I just briefly, it's kind of draw task. So they manipulate attention and to have an unconscious or unseen versus seen stimuli and test the predictions from these theories. That's the task 2. And then task 2, experiments is kind of interesting because it's involved gaming.
Yeah.
But anyway, that's it, from me. And Changshan have nothing to say. So shall we finish now?
Yeah.
Okay, then see you next week. Bye-bye.
Bye.
Okay, I'll stop recording.